All right, so now that you guys kind of get a general idea of the circumscribed angle theorem, about how circumscribed angles are supplementary to the central angle. So we talked about last time how this is a kite. Kites have to add up to 360 degrees, and if both of these tangent lines are perpendicular, they're 90 degrees each. These two, it leaves it to be 180 degrees left over that they have to add up to. So now, what kinds of problems are we going to get when we're talking about a circumscribed angle theorem? Great question. Let's look at a few examples. So as you see up here, the circumscribed angle theorem is still written. The circumscribed angle is supplementary to the central angle measure. So it adds to 180 degrees. Now we might look at example 1 here where we have a circle. It has the two radii on here, a couple of tangents, and they're asking us to find the measure of angle ABC. So if we look at measure of angle ABC, that's telling us we're looking for our tangent, or our circumscribed angle. We're given that AC, this arc right here, is 120 degrees. So that doesn't tell us too much, because what we need to know is that, or all we know is that the circumscribed angle theorem is the circumscribed angle is supplementary to the central angle measure. So if they are supplementary to the central angle, we need to know what this guy is right here, this central angle. And we don't know what that is. But we know this arc AC is 120. And if we look all the way back at our central angle theorem, that's when the measure of a central angle in a circle is the same as the measure of the corresponding arc. We know our central angle, or we know our corresponding arc is 120 degrees, so our central angle is also 120 degrees. Now we can use our circumscribed angle theorem because it's supplementary to the central angle that we're given. We know our central angle is 120, so if I do 180 minus 120, we're left with 60 degrees in here. And if we want to check our work, we know that these have to be tangent, or because these are tangent, that makes these perpendicular. So we'd have 90, 90, and we could do 120 plus 60 plus 90 plus 90, and all of those add up to 360 degrees, which is what we need for this kite that was created here. Now, another type of question that they'll ask you with circumscribed angle theorem questions are, what is the value of x? So in this case, we have x here is 2x minus 1. Now, we haven't talked really at all about solving for these, but what we did talk about is how this is a kite. And we talked about how when you have a kite, that means you have two sets of adjacent congruent sides. So we said our radiuses are always congruent to each other, and that makes our tangent lines congruent to each other as well. So all we have to do is say, okay, these are both tangents, so my 17 has to be congruent to my 2x minus 1 because those are both the tangent lines. So I write that out as 17 equals 2x minus 1, and then I just do some algebra to solve. So I don't want this 1 here, so I'm going to do the inverse operation of addition, add it to both sides. Those add to 0. I'm left with 2x on one side. 17 plus 1 is 18. Now I know 18 equals 2 times x, so I want to undo that. I do the inverse operation of multiplication, which is division. We divide, those divide to 1. 18 divided by 2 is 9, so 9 equals 1x. Final answer. So whenever you have a circumscribed angle theorem question, there'll usually be two parts. First part being what is the angle that they're looking for, and the second part being what would the measure of a tangent line be, or a variable within that. Now let's look at example 2 here. If we're looking for PN, so we're looking for this guy right here. It's an arc. We know NMP right here is 90 degrees. So that's our circumscribed angle is 90 degrees. If we're looking for PN, we know this is the corresponding arc for this central angle. So if we can figure out what this central angle is, we can figure out what the arc is. Since we know the circumscribed angle is supplementary to the central angle, we could do, this is 90 degrees. Supplementary means they add to 180, so 180 minus 90, we're left with 90. That's nice. So if this is 90 degrees for our central angle, and our central angle theorem says that the central angle is congruent to the corresponding arc, if this is our angle for central angle, corresponding arc is right there, same one, also 90 degrees. So PN is equal to 90 degrees. Then this question is also asking us, what is the value of y? If we're looking for y, that is in here. That's one of our tangents. Oh, and look, we have another tangent is 56. We know that because this makes a kite, even though this one actually turns out to be a square, it's still a version of a kite because we have two sets of adjacent sides. And even with squares, you know, all sides are congruent. So, you know, this has to be congruent to this. So I can write that into an equation. We know 7y is equal to 56. I'm going to divide by 7 on both sides, and we're left with y equals 8. All right. That is all for you today. If you have any questions on circumscribed angles, please let me know, and I'd love to help you out.